I have a bucket full of gummy bears. Do I have puzzles for you? No. Maybe. I know, we haven't had any in a while. All right. Number 1. 3N. What? Oh, son of a motherless goat. How many people spotted the fun font? It's Pokemon. Look at that font closely. How do you fit 23 Charmanders into a locker? Huh? What? No. How do you fit 23 Charmanders into a locker?
I don't know.
You Pokemon. You poke them in. Poke them in? Kinda. Would be better maybe to say elevator. Because you get on an elevator. Pokemon. That would be better. Alright. Anyways. 3 over n squared. Everything's worth 1. You decide if you get what you should get. 1 over 216v to the 7th. If you need to know why an answer is what it is, stop me, okay? Because I'm only writing answers. 1 over m to the 9th.
I have a question.
Okay.
For number 2, would v2 over 216 v9 work?
No.
Why not?
Because it's not done.
Oh, okay.
You can have a half mark.
Okay, cool.
Number 4. 1 over 3p cubed. Anybody want to ask about any of them? No? Lovely. 5. 1 over n m 20 n to the 22. 6. 1 over a 14 b 6. 7. Negative 1 over x 7 y 4. And 8. 1 over x to the 11th y. Any questiones? Going once. Going twice. 7 and 8. Certainly. So 7, as always, I like to deal with the top first. So that's 4 minus 3 plus 3. So the y's are just gone there. So I've got x negative 3, y to the 4th. Yeah? Over negative x squared is positive x, right? And then squared again is x to the 4th. Yeah? So I've got x to the 4th and y to the 8th. But the whole thing is negative. Everybody still good? Negative 3 minus 4 is what? Negative 7. So I've got negative x to the negative 7. What's 4 minus 8? Y to the negative 4. Are negative exponents allowed? No. They go to the other spot. Either down if they're up or up if they're down. You good, Harmon? Sweet. And number 8. Again, I like to tidy up the numerator first. X and x to the negative 4 is x to the negative 3, y to the negative 1 over. Now, negative x squared, right? Since that negative is going to the 4th power, what's going to happen to it? It's going to be positive. So this down here is really x to the 8th, right? This confuses you, some of you, a bit because of this. You all know that negative x squared is positive, right? And you all know that negative x squared is negative, right? So in there, whatever x is, right, the answer is going to be negative, isn't it? But that negative goes 4 times. Negative, negative, positive, negative, 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 positive. Right? That's why this is happening. So then, negative 3 minus 8. Negative 3 minus 8. X to the negative 11, y to the negative 1. Is that allowed? No. Why? And we wouldn't write 1. You good? Excellent. Remember, if you have some of my answer, you've done some of the exponent work right, so give yourself a half a mark. Okay? Turn the page over. 6b squared minus 28b plus 30. 56n squared plus 32n minus 24. 24n squared plus 2n minus 40. 40v squared plus 11v minus 21. 14x cubed minus 47x squared minus 13x plus 21. Then it will show up magically. And 56n cubed plus 26n squared plus 46n plus 40. 1 mark for all those. If you have a negative or something in the wrong spot, you lose a half a mark. But by all means, double check with me, because it's entirely possible I made a small mathematical error when I made this key in 10 seconds. So if you're very confident in your polynomial multiplication, number 10, seven times 8, 56n squared. 7 times 8 plus 56n. 3 times 8 minus 24n. 3 times 8 minus 24. Well, 56 minus 24 is 32. Because of course you would collect your like terms, right? Anybody else? Going once? Going twice? Going thrice? What? Yes. Now, while you are working today, I will be marking your contests, and I will let you all know who the big wiener is. I think Mr. DeVries is taking the top 3 to the contest. Amy says the Waterloo one was very difficult.
It wasn't difficult. I mean, it is, but I just...
Not on that one, maybe. I don't know.
On the grade 9 you did.
I don't know about the Waterloo one.
all writing, and it's the worst 10 marks. So,
Lena Goot is making a funny face. All right. So we have marked. When will you tell me what you got on that? At least on your next test, possibly before if I have some spare time. All right. Let us move on, cabbages, to page 120. I don't know. My sheet's not sliding. Whatever page that starts with simplifying radicals. 121. Although I'm the worst kind of liar because first we need to make sure everybody's cool with this stuff. So, This is negative 14, so it's an integer. If it fits into integer, it fits into everything else, right? Remember, it goes natural, whole, integer, rational. So if it fits into integer, it's also automatically rational, right? Right. This one is irrational because there is no root of 27. This one is 3 over 10, which is rational. It's not an integer, it's not a natural, it's not a whole. This one is irrational. There is a root of 225, but there's no root of 48. This one is 0.5 or 1/2, so it is rational. This one is 1/5, so it is rational. This one is 0, so it is whole. If it's whole, that automatically makes it an integer, which automatically makes it rational. This is irrational. This is irrational. This is 11, so it's natural. This is tricky. What's this one? It's a quarter, so that is 1/4, so it's 1/2, so it's rational. A lot of kids see that and say, there's no root of 5 and no root of 20, and they forget to simplify 5/20ths. Did I catch any of you guys? Or any of you ladies? No, I didn't fool any of you? Excellent. And that one's irrational. Cube root of 576 has to be 8 and a bit, right? Right? Very close to 8, doesn't it? Because 576 is a little bit past 512, right? It's like 50 out of 200, right? Because 512 to 729 is a little more than 200, right? So it's about 8.25, but it's a little less than that, so I would say 8.2 would be my guess. Right? Let's check. Wake up, calculator. I said wake up.
is it irrational?
Oh yeah, it's irrational. But then I said I wanted you to estimate it too, right? Math.
Wondering if I got it right or not.
Yes, it is irrational. Cube root 576. Oh, 8.3, I was close. $17.28. Is that rational? Nope. So it's irrational, and you would do your... There's lots of ways to do the estimate here because it's way more than 400, isn't it? Here is... Did anybody bother to try and do an estimate of this to figure out how to do it?
I got it irrational.
Yes, it is irrational because you punch it into your calculator and filled up your screen. Is that not very close to 1,600? What? And is that not 16 times 100? And does that have a square root? What is it? 4. Does that have a square root? What is it? 10. So the square root of that must be 4 times 10, yes? Which means that must be a little bit more than 40. So your guess would be negative 40. And when you punched into your calculator, which you all did, you got 41. Of course, the negative out in front makes that negative, right? What about this one? Cubed root of 27,000. It is indeed 30. Your calculator proved it. Why? Because that is the cubed root of 27 times 1,000. What's the cubed root of 27? 3. What's the cubed root of 1,000? 10. 3 times 10 is 30. What about that one? You punched it into your calculator, and what'd you get? 15. So it's fine. What about that one? 270. Again, that's 729 times 100. 729 square root is 27. 100 square root is 10. 27 times 10 is 270. What about that guy? Square root of 100,000. So that's the square root of 100 times 1,000, right? 100 has a square root. Does 1,000? No. So that one's irrational. How could you estimate it? Well, you know it's going to be 10 times something, right? So it's the square root of 100. And then this is another 100 times 10, right? Square root of 100 is 10. Square root of 100 is 10. Square root of 10 is just about 3, isn't it? So that our guess would be 10 times 10 times 3, which is 300. Everybody cool? Sweet. Cube root of 1728. I think that exists. I can't remember. 16, isn't it? 12. Square root of 529? 23. Cube root of 1,000, you know, is 10. What about this guy? Nope. 14 over 15. What about that one? Irrational. And it's just a little bit more than 11, right? Because 121 is a perfect square. If you wanted to go even better than that, you would, of course, say 121, and the next one is 144. That's 4 passed out of 23, right? 4 out of 23 is basically 1/6. So that would be 11 and 1/6. Cube root of 64 is 4. That's on your list. Cube root of 0.125. A lot of people have trouble with decimals. 0.125 is 125 over 1,000, yeah? Cubed root of 125 equals 5 over the cubed root of 1,000 equals 10. 5 over 10 is 1/2. 5 over 3. And irrational, but it's close to 4. 64 is 4. 125 is 5. So it's between 4 and 5, right? Right? So that's about 40, right? 64 to 102 is about 40. 64 to 125 is about 60, right? So it's 4 and 40 over 60, which is 4 and 2/3, which is 4.67. Yeah? Yeah. A plethora of good work. Surface area of a cube, its side lengths are 15. If it's a cube, how many surfaces does it have? 6. And they are 6 squares, right? So how do you find the area of a square? 15 squared. 15 squared is 225 times 6 is 1350. Surface area of a cube with the volume of 216. Well, if volume equals 216 and volume equals the side cubed, then that must mean side cubed equals 216, doesn't it? How do you find S? Cube root. So S is 6. Now I need the surface area of that cube. 6 times 6 squared is, oh my goodness, 216. Same number. Are they the same number? No, because one is cubed and one is squared. Yeah? Yeah. And I think that was it for homework. Everyone is good? Lovely. Please turn to 121, simplifying radicals. A radical is any expression with this symbol. It'll show up. There it is. Now, you guys know that symbol is a square root. That's what you call it. It's a square root symbol. But no. Because now you have been introduced to the fact that that symbol right there can have a number right there. That number, who remembers what it's called? The index number. That number tells you the root that you are looking for, right? If it is a 2, then you need 2 factors, blank times blank, and they have to be the same. I'm going to use m. If it's a 3, then you need m times m times m. You're looking for 3. If it's a 5, you're looking for groups of 5. If it's a 12, you're looking for groups of 12. Everybody understand? Okay. So, we are going to write in here one more word. You know what the index is. This word, the thing under here, is what is called the radicand. You will never use that word in real life even once. But I will use it in math class all the time because we are discussing radicands. So I will use its name. Much like when I am discussing you, I use your names. I do not say that girl that sits in the front and wears glasses and is from Germany. I call her her name. Right? Everybody good? All right. Now, please watch. An entire radical, and I'm going to highlight the word entire, is index, radical sign, radicand. Too many A's. The radicand. Radicand. That's what an entire radical looks like. These we are usually trying to simplify into a mixed radical. I don't know why both my eyes just disappeared there. I'm blind. My eyes disappeared. We are usually trying to simplify an entire radical into a mixed radical. A mixed radical is this. Y x root radicand. The mixed radical. Holy, my eye disappeared again. Now I'm a cyclops. Because I only have one eye.
I thought we were past that.
Okay? This y is a coefficient, which means what math is it doing to the radical? What do coefficients do to what follows them? Multiply. No, they don't kill them. They are multiplying the radical. I'm going to go ahead and turn this off because my eyes keep disappearing. Now I can't even turn it off. Okay, so convert to a lowest terms mixed radical, right? That's our goal here. We have 72. Now remember I told you we were never going to be using decimals again when we are doing square root, cube root, x root, okay? They have disappeared. They are out of our lives. This is what we call finding an exact answer. Because if I punch 72 into my calculator, I know I'm going to get 8.48 blah, 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 right? Is that number exact? Yes or no? 8.4815 blah, 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 blah. If I put the square root of 72 in my calculator, is my calculator give me an exact answer? No, because that decimal goes on forever because it's irrational, right? So this is what math people do to keep the answers exact and tidy. Here is what you do. I'm going to show you the longest way possible to do this first. Then I'm going to show you a shortcut. Okay? Step 1. Prime factorize your radicand. So what is my radicand in this question? 72. So I got to do the prime factoring of 72. Do I care how you do it? Some of you will use trees. Some of you will use those little stairs like I do. I do not care. 72. Most of you are probably going to go 8 and 9. 2 and 4. 2 and 2. Foop, foop, foop. 3 and 3. Foop, foop. Right? So now I know I'm going to rewrite Radicand. So now I do not have the square root of 72. I have the square root of 2 cubed times 3 squared. Yes? Everyone cool? All right. Did I write an index number there? Jalem, if there's no index number there, what's the index number? 2. Right. Absolutely right. Since it's 2, that means I'm looking for factors that are the same, correct? Right? Do I have any groups in there of 2? Yeah, I do. What? I got 2 2s, because there's 3 of them under there, right? So there's one group of 2. And I got 2 3s. So there's a group of 2 3s, right? So step 3 is remove your groups. So I used to have 2 times 2 times 2 and 3 times 3, right? There's a group of 2, so it comes out to the front. There's a group of 2, so it comes out to the front. Now what do I have out in front? I took out a group of 2, right? So I have 2 and 3. No, because I'm looking for groups of 2, right? Because the square root, I need 2 factors. Square root of 4 is 2 times 2. So the 2's, it's 2. So I brought out a 2, I brought out a 3. And what did I leave under the radical sign? A single 2. These numbers out in front are what? Coefficients. So what do? Multiply. What's 2 times 3? 6 root 2. And that is the answer we seek. Is everybody good? Yeah? All right. So we're going to do the first two the long way, and then I'm going to give you a shortcut. So what's our first step with 99? Prime factor. What is it? 3 times 33. There's 1. And then what? 3 times 11. Do you see a group of 2 there? Where? The 3's. So what comes out? 3. And what stays under there? 11. Done. Everybody good? 75. Break it down. What are you going to use? I use 25 and 3. Then what? 5 and 5. Is there a group of 2? Where? 5. So what comes out? 5. What stays under there? 3. Is everybody good? All right, now, remember how I told you your life would be easier if you could memorize the perfect squares? Don't write down what I'm about to write down. Square root of 99, square root of 75, right? That's what we just did. Yeah? Okay. 99, isn't that 9 times 11? Why would I choose 9? Does 9 have a square root? What is it? 3. So what would come out? 3 root 11. Everyone see how helpful it is to know the perfect squares? 75 is 25 times 3. What's square root of 25? 5. Out comes a 3. So if you can see a perfect square factor, you can save yourself a lot of time. Or look what happens with letter C. 80. Well, 8 times 10, there's no perfect squares there. It ends in 0. I better just try breaking it down, right? So 80, since it's even, I'd go 2 and 40, right? Right? And then there, I'd go 4 and 10. Why will I stop at 4 even though it's not prime? I'm going to get a group of 2 there, aren't I? So 4 times, now, 10 is 2 and 5. Oh, there's another group of 2, right? So 4 times 4 times 5, right? What's the square root of 4? 2. What's the square root of 4? 2. What did I leave under there? 5. What do I do with the 2 2's? Multiply. 4 root 5. Now, what if I had done this? 80, since it ends in 0, it'll divide by 5, right? 5 and 16. Can I stop there? Why? 16 is a square root, and that square root is indeed 4. Everybody with me? So, what is a perfect square that will go into 300? If you were making a factor tree, what's your first one here? What would you use? I would use 3 times 100, wouldn't you? What's the square root of 100? 10, so what comes out? 10, what stayed under there? 3. Picking up what I'm putting down? I know. 63. What most of you are going to choose, your very first branches of your factor tree are going to be what with 63? 9 and 7. You can stop there. Why? No, 9 isn't prime, but 9 has a square root. What is it? 3. So what comes out to the front? 3. What did I leave under there? 7. Everybody picking up what I'm putting down? What about 32? You could use 8 and 4. Or you could do 2 and 16. Why would 2 and 16 be better? 16's got a square root, so what comes out? 4. What stayed under there? 2. 363 is a big number, right? So you'll probably have to prime factor it, right? 363. Now, 3 plus 6 plus 3 is 12. Does 12 divide by 3? So 363 divides by 3, doesn't it? 3. How many 3's fit into 3? 1. How many 3's fit into 6? How many 3's fit into 3? 1. Can I stop there? Why? Square root of 121 is 11. So what's coming out to the front? 11. What stayed under there? 3. Brilliant. Is everybody Gouda? Excellent. Now, we're going to work the other way. Now I've got it simplified, but I want it as an entire radical. How would I do that? Well, it's just backwards. What's the little number that should be there that we don't write? 2. Which means I was looking for groups of 2, yes? So if there's a single 2 out here, how many 2's had to be under there? 2. So this would be the square root of 5 times 2 squared, right? Which would be what? Square root of 20, right? Okay. What's the little number that should be there? 2. So what should this really be? 29 times 7 squared, which is 29 times 49, which is a big number that I can't do in my head. Well, I could, but what is it? 29 times 49? It's got to be around 1,400. 1,421. Everybody see how it works? Now, please notice you should see a little pattern. Coefficient index. Coefficient index. Coefficient index. Coefficient index. Right? So what's this one? What's C? Put in the index. 4 times 6 squared. What's 6 squared? 36 times 4. 144. Whoa, tricky. What goes back under there? 5 squared. Because that negative isn't part of it, is it? But the negative stays out front. Negative root 12 times 25 is 300. Is everybody good? Anish.
What if that negative 5 was in brackets then?
Can't do it. Because negative 5 can't be a root of something, can it? Actually, you could, but we're going to leave it at that. For your level, we're going to say you can't. All right, let's have a look at 3. What's different in 3a than in 1a through f? There's an index of 3, which means I'm looking not for a group of 2, but a group of 3. Do you think any other thing changes? No. Remember, when we were looking for a square root and we were doing our factor trees, if we found a perfect square, we could stop, yes? What do you think we can do if we're doing a cube root? If we find a perfect cube, we can stop, right? So, I'm going to show the shortcut because I've done this a million times. That is 27 times 2. Why am I stopping there? Is 3. So what comes out? 3 cube root 2. That's how we read it. Now let's pretend you didn't know 27 was a factor of 54. Then you got to break it down, don't you? Does it save you any marks to break it down? No. Does it save you time? Yes. So do I care if you do this? No. You might have to break it down. Most of you probably would go 9 and 6, 3, 3, 3, 2. There's your group of 3. Everybody with me? Now listen to me closely. Remember how I said yesterday when we were listing all those perfect squares and cubes, there was one other thing that I said would make your life very easy to memorize? Now's the time to learn it. 2 to the 0 to 10. That is really good to memorize. 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. It's good to get that up to 10. 16 is 4. 32 is 5. 64 is 6. 128 is 7. 256 is 8. 512 is 9. And 1024 is 10. It's really good to know the 2 power. It comes up a lot. Okay? So let's look at B. Can any of you think, since it's a cube root, I should be looking for perfect cubes? Can any of you think of a perfect cube that would go into 144? If you can't think of one right away, then what must you do? Break it down. 144 is 12 and 12, which is 2 and 6, 2 and 6, which is 2 and 3, which is 2 and 3, right? What do you see? 1, 2, 3, 4. So there's 2 to the 4th. 3 and 3, 3 squared. What size group am I looking for? 3. Can I get 3 out of any of those? Yeah, I can get out a single 2, but that only took out 3 of them. So what did I leave under there? 1, 2, and 3 squared, which is 2 times 9, which is 18. Is everybody good? Yeah? Okay. What's different in C? It's 4. So I'm looking for a group, what? Group of 4. Now, I told you 128 is 2 to the 0. 1, 2, 3, 4, 5, 6, 7, isn't it? I have that memorized. So I know that is the 4th root of 2 to the 7th. Can I get 4 out of 7? How many times? Once. So I can get a 2 out. And what did that leave under there? Thank you. I've been waiting for somebody to say it. I've been saying under there 17 times. God, I don't know what I have to do to make you guys understand how I work this place. I just made Marley say underwear. But what did I leave under there? 2 cubed. Now, would I leave 2 cubed written as 2 cubed? I know it just went blue. Don't bother. I would not write 2 cubed, would I? 8. Is everybody Gouda? Yeah? Yeah? Yeah. Try D. Go. I have D memorized because I have also memorized 3 up to 3 to the 5th. $162 adds up to 9, yes? So it'll divide by 3, correct? 3, and that's 54, right? Right? Now we just did 54 right here, didn't we? Cube root of 54 is 27 times 2, right? 27 times 2. Yeah? I can stop there, can't I? Because I know 27 is 3 cubed, right? And there's a fourth 3, right? What size group was I looking for? 4. So I bring out a 3, and what did I leave under there? 2. Right? Now, if I had done this, 162, 2, and 81, I can stop there because I know the fourth root of 81. I know that it's 3 because it's 9 times 9, 3 squared, 3 squared, 3 to the 4th. Everybody good? Please notice that all this stuff I'm doing is only saving me what? Time. It does not make me better at doing the math than any of you. Do you understand me? Gouda. Okay, let's look at 108. Cube root of 108. Right? Okay. On this page, you have what you need to solve that. Isn't 108 54 times 2? And isn't 54 27 times 2? And doesn't 27 have a cube root? What is it? So what comes out? 3. What stayed under there? There was this 2 and this 2, right? So it's 4. Everybody good? What's different in F? Square root, so I'm only looking for groups of 2, right? Break it down, go. Get it? MC Hammer, break it down. Can't touch this? Nothing? Okay. Which he, of course, stole from Rick James' song Super Freak. I happen to know that that is 36 times 3. Why did I use 36? It's got a square root. What is it? 6 root 3. If you didn't know about 36, you break it down, right? Most of you probably went 12 times 9. I hope. And then you stopped at 9 because 9 has a perfect square. And then you went 4 times 3 and you stopped at 4. Why? 4 has a perfect square. So the root of 108 is 4 times 9 times 3. What's the square root of 4? 2. So out comes a 2. What's the square root of 9? So out comes a 3. What do you do with those two numbers? Multiply them, and what'd you leave under there? 3. Does everybody see how easy this is? 1 second. Because it's not going to stay that easy. Turn the page over. What is that? Variable, son. Damn. That font is my actual favorite font. Cocktail Bubbly. That is my favorite that I have found so far. Overall. So, what is the radicand in this first one? 32x squared, right? So this is the same as the square root of 32 times the square root of x squared, right? Do we know how to break down 32? We've done it already. Marley told us how to do 32. What did you use? 2 and 16. 16 times 2, right? What of that is moving out to the front? 4, because the square root of 16 is 4. So out comes 4. X squared. Well, isn't that x times x? So isn't that a group of 2? So what comes out? X. So what's the answer here? 4x, and what did I leave under there? A single 2. Is everybody with me? Please notice there's an excellent shortcut, but I won't tell it to you yet. What are we doing with 48x 7y to the 5th? And it's cube root. Can you think of a cube root, a cube that goes into 48? It's probably the first branch of your factor tree. 8 times 6. Right! It's 8 times 6. Does 8 have a cube root? What is it? So what comes out? 2. Now, look closely. I need a group of 3, and I have 7. How many times does 3 go into 7? Twice. And it leaves a remainder of 1, right? So I must be bringing out x squared and leaving an x. How many times does 3 go into 5? Once. So I'm bringing out 1y and leaving how many y's? 2. And what number did I leave under there? 6, because I took the 8 out. Does everyone see how to do it even with variables? It's easy, right? You're just counting groups. Right? So I just want to make sure you guys tell me the cube root of 56 x to the 4 y to the 10th z to the 3rd. Do that one, because I don't know if I totally believe you. Oh, I'm going to add a squared. Oh, done. That was a Richard move.
Oh, because Richard means dick. Oh.
Being a teacher was kind of hard. Kind of was fate in society.
Okay. Break down the number. What is it? 8 times 7, right? Why did we use 8 and 7? Because 8 has a cube root. So what's coming out? 2. So 8's gone. 2. How many x's can come out? 1. How many x's are left? 1x. How many y's can come out? 3. How many y's are left? 1. How many z's can come out? 1. How many z's are left? None. How many a's can come out? None. So how many a's are left? A squared. So what's the final answer? 2. X, y, cubed, z, cube root 7a squared. Can everybody simplify a radical? That makes a guy happy. What doesn't make a guy happy is piss poor technology. I'm waiting for my computer to stop being frozen. That's what I'm doing. I know you were. All right. I want you to do the rest of 133 or 123, 124 now. 124, number 6, G and H. Please notice this instruction. See if you can figure it out. And then you do 125 if you need to. The answers are there. That's your homework for the weekend. Everybody good? The rest of 123, 124, and 125, I would do a little bit of practice on there. Make sure you know what you're doing. Everybody good? Great. I am an idiot. Anish pointed out that I forgot to write that X and that Y in here because they were left under the radical sign because I could only take out one X and 3 Y's. So that was a big mistake, which I am going to edit somehow back into the video I have just made and tack it on the end. And I'm still admitting to it because I made a mistake. And if there's one thing I believe in, it is admitting to and owning up to your mistakes. Especially since nobody else in North America does. It's always somebody else's fault.